Welcome, Hornets. Today we're going to be discussing the fourth of our tests called the integral test. This follows the nth term test, the telescoping test, the geometric series test, and the p-series test. So we have the p-series, geometric, telescoping, and now the integral test. The integral test has three conditions that are required, assuming that we have a summation as n equals 1 to infinity for an a sub n. Now, if we have a situation where a sub n is positive for all terms generated by n greater than or equal to 1, our first condition is satisfied. The second of the three conditions is that a sub n is continuous for all n greater than or equal to 1. For all n greater than or equal to 1. Now the third condition that we have is that a sub n is decreasing for all n greater than or equal to 1. And that means that f prime of x is less than 0 for all n greater than or equal to 1. Now, if these conditions apply, I repeat, if these three conditions apply, we can then look at this summation as an integral. Now, it is absolutely imperative that you understand that just because I find a sum from this integral, that is not the sum of the summation. If I get a sum, that simply tells me that the summation converges. Whereas if my integral gives me an infinity or negative infinity, I have a divergence. So let's take a look at an example, please. We're just going to go ahead and we're going to start with n equaling 1 to infinity of n divided by n to the fourth plus 1. And the question is, does this converge or diverge? Now, the first thing we have to do is make sure that we can use the integral test. And it also means that the very first thing that I want to do is check and make sure that my limit as n approaches infinity is equal to 0. After all, if it doesn't, then I immediately stop and I say, I am looking at a divergent situation. Well, according to Feppel, the larger factorial or polynomial, is in the denominator. It is the faster function, and therefore we go to 0. So yes, it potentially will converge. And notice, I can't say it does, I say it potentially does. So I'm now going to check. Yes, a sub n is greater than 0 for all terms generated by n greater than or equal to 1. Number 2, I can also see that a sub n is continuous for all n greater than or equal to 1. And finally, I find my derivative. Now, I've already found the derivative, and if you do it yourself, you're going to find that it's 1 minus 3x to the fourth power divided by x to the fourth power plus 1, the quantity squared. Now, if you look at it, I plug in n equaling 1, I'm going to get a negative value. And if I plug in any value greater than 1, I will also get a negative value. So my derivative will always be negative for all values of n greater than or equal to 0. And I can now say that this summation from n equaling 1 to infinity of n over n to the fourth plus 1 can be considered the integration from 1 to infinity of x over x to the fourth plus 1 dx. Now, this is what I'm going to have to work with. You can tell that it is an improper integral. We can also see that I'm probably going to want to use a u substitution. So let me go ahead and rewrite this on the next piece of paper, and we're going to go ahead and finish our process. So I am looking at the summation from 1 to b. I'm letting the limit as b approaches infinity. This is our structure. We're looking at x over, and I'm going to call it x squared squared plus 1 squared dx. Notice I can now use the u sub equaling x squared. 1/2 du has to equal the x dx. And so I'm going to go ahead and I'm going to use my u sub. The limit as b approaches infinity for 1 to b. I'm going to put my 1/2 in front, and I'm looking at 1 over u squared plus 1 squared du, and that is arctangent. So I'm looking at the limit as b approaches infinity for 1/2 the arctan of x squared, and I'm going from 1 to b. Here we go. So when I plug it in, I end up with the limit as b approaches infinity for 1/2 the arctan of b minus 1/2 the arctan of 1. Now, we know that the arctangent of 1 is pi over 4, so I can immediately replace that with a pi over 4. I also know that my limit as b approaches infinity, the arctan is approaching pi over 2. So I'm now going to simplify this. I can call it 1/2 of pi over 2 minus pi over 4. That leaves me with a pi over 4 simplified to pi over 8. Now, because this had a sum, I can now state that the summation as n starts at 1 to infinity for n divided by n to the 4th plus 1 must converge by the integral test. And this is what you'd have to do each time you wanted to check. That's the integral test. That's what we're going to be working with. And trust me, it isn't as bad as it appears. And it is but one of several tests that you will be able to choose from at the end of this chapter when deciding what to do. All right. Thank you very much, Hornets. That is my lesson for today. I hope this has helped you, and we will continue to work with the integral test over the next several days. Thank you very much. Please be well and take care. Bye-bye.